Hello, everyone. Today is May 29th, 2024. This is the Kubernetes Data Protection Working Group meeting. So I think today, let's see where we are with this CBD cap.
We had some feedback and we've been responding. I think on the Sidecar side, Prasad has initiated adding some of the Kubernetes protobuf definitions over there. So yeah, so we started working. Daniel, I think Daniel's on the call. He started looking into the repo management aspects too.
Oh, okay. Actually we have a pull request. Okay.
Exactly, yeah.
Oh, good. All right. Let's see.
Yeah, we're looking into it still, yeah.
Okay. You can also review this, right? So
Yes.
yeah. Okay.
Yeah.
And hey, sorry. So who is it's Daniel is also working on this one.
Right.
Okay. All right. And the cap. So, have you addressed all the comments? Let's see.
I think then we've addressed all the comments pending.
Okay.
I haven't responded to some. I responded to some. I don't know if there's anything pending.
Okay,
Yeah.
so there's one thing she is asking someone from SIGAuth to take a look. I asked Yvonne who would be a good person because you guys did go to the SIGAuth meeting, right?
We
So
did, and we
some
applied the
people,
feedback, yeah.
so some people there maybe, so who is more familiar? It'd be good if someone who was in that meeting who can, invite those people to review this will be better. They have some background. Do you know who? Yvonne was telling me Clayton. Was Clayton in the SIGAuth meeting? I thought Clayton was normally not.
Do we know when was the SIGAuth meeting? I forgot.
It was a while ago, so it's good to to pin someone, right, and then just pin them in here and also pin them on Slack. Otherwise, they are not going to automatically review this. I think I see that Yvonne added SIGAuth as the participating SIG, but they are not going to just to start reviewing this if you don't pin them, right? So we need to pin them. Yeah, it would be good if you know who you talked to last time. Will be better, so they have some context. Otherwise, you just I don't know.
Yeah.
Ben, you have any ideas? Who should pin from SIGAuth to review this?
I don't have any contacts or any contacts on that team. I mean, Clayton is pretty high up. I think he might probably works across multiple SIGs, so he might, if he can't do it himself, he might be able to find someone. But I also don't know if you'll be able to get a hold of him.
I was just worried. Too busy.
So there's a SIGAuth Slack channel. You can just join it and be like, hey, who here can help me review a cap? And just demand attention in the Slack channel. And someone will probably respond to something.
Yeah. So I think Jordan is he's in SIGAuth. I think Mochen, if I got his name right, and yeah, there are a few folks there. I just don't know who you talked to last time. Right? It'd be good if it's one of those guys who are actually in that meeting. I think normally the leads in SIGAuth, normally they are in those meetings. So if you don't remember, maybe you can just pin a few of them on the Slack channel.
Okay.
Yeah. Because Michelle says I think she says she does not have like major concerns, right? But she's just asking someone from SIGOS to take a look. So yeah, Carl, can you do that? Can you
Sure.
find someone and just pin them on Slack?
Yeah, I'll try.
Then
I'll,
you can then
yeah,
maybe
try to correlate.
assign to someone here. Yeah.
Yeah, I'll try to correlate with, if I can find the date, and I can see if I have the names of the people who attended.
Mm-hmm. Okay. All right. Yeah, that will be. Then we need to do that so we can get this move forward. Yeah, that actually may be the main thing. So okay, and then the deadline. So let's see. Cap merge. Let's see. Cap merge deadline is June 13th. Yeah, so we should yeah, try to get someone review this as soon as possible. Okay. And then you're good now, right? With the contribution, you got approval, right?
I think so, because I mean in the cap,
But
right?
you still say waited.
No, I think it's okay. In the cap, I was just looking, I'm not sure I saw this before, but it says that, Prasad, me, and Ivan all have covered CL, authorized under signed CLA. You go look at just one of the early comments in the cap, you'll see that.
Okay, so we're not waiting anymore.
I think so, yeah. Mark might,
Mark has different opinion.
Mark's on the call, sorry.
See, Mark, do you know? Mark is on mute if you're talking. Are you actually in the meeting? I'm not sure if he's in the meeting. He's showing up here. Maybe he's busy with something else. Okay. So yeah, then we can basically get this going. Yeah. Anything else about this? I guess CSS spec, I think it's okay, right? We can wait on that one. CSS spec release. I think you can just use some commit ID for now to do your work. When you submit PRs in this repo, you can just use the commit ID from the CSS spec repo, right?
Yeah.
Release for now, yeah. Okay. All right. Anything else about the CPT?
No.
No. Okay. So for the replication, yeah, I have some questions. I was looking at that. So I was hoping Tom's not here. I should have some questions for him, like because I want to ask him if he has some volumes that are both in the he has, I think they have this separately in DOS design. They have this volume group snapshot and the replication group, they're separate, right? So, but if a volume is involved in both, how does he do that? I just have this question. So Ben, going back to, I know we had this discussion a long time ago. Initially, I have that combined, and then we separated that because we thought it's hard to reach consensus there. But I still want to know.
Wait, so what was the specific question? This is a
I was just
question about groups.
wondering if I have a volume that I need to be in both. How do we do that? I mean, I believe he has done that.
You mean like a group of volumes that are being replicated and a group
And
of volumes that
also
are being
snapshot. Yeah, and
snapshotted?
also, so there are two different groups, right? So how?
But are the groups identical, or are they overlapping, or are they non-overlapping?
Well, I think the way we designed it right now, they're separate, right? So it's just because initially, remember, I have this warning group that can do both. right? The voting can be in multiple groups, but now since we separate this, I'm just wondering how that's handled. Because
I mean, there's lots of options. I mean, like it's totally reasonable to have an approach where you only have one kind of group, and like you have different things you can do with it. The problem with that, I think, is that like no user is going to use that interface, right? Because it's too complicated to figure out. Like, okay, this group can sometimes create snapshots and sometimes replicate and sometimes both, but like you got to ask. Like it's the interface would be too weird. Like unless you don't care about portability, it comes down to whether you care about portability, right? Of course, any proprietary system can design an interface that's ideal for like that one storage system. But if we're trying to design an interface that works across all the storage systems so that people can write applications that are like write once, run anywhere, I don't think that a single group type would work, because like what one system can do and what one system can do overlaps so little that like the likelihood that you'll have an interface that'll work on even two systems is very low, I think.
so I guess I want to know how, if let's say you want to be in both groups, how does that coordinate? I guess I was just
so I don't have any problem with having like two different kinds of groups, right? Like you have a volume snapshot group, which might not even have a group. It could just be like, here's a bunch of volumes, take a snapshot of them at the same time.
That's how we design it right now, right?
It's an implicit grouping, right? So one could say that, okay, so I have a replication group with 4 volumes in it, and they're replicating over here to these 4 other volumes. And anytime I want to, I can take a snapshot of those 4 volumes and I'll get a consistent snapshot of those 4 volumes. It gets weird when someone says, well, actually, I want to take a snapshot of those 4 volumes and this 5th volume that's not in the replication group. Like, can you do that? Like, well, that's going to depend on what the storage system can do. Some storage systems will say, sure. Others will say, no. The set of volumes you take the snapshot of must be identical to like the replication group that they're in, because the snapshot mechanism is going to leverage something down at that layer. I mean, trying to solve all the problems at the same time, I think is too hard. If we design a solution that works for snapshots, I mean, design a solution that works for replication, and then an individual vendor says like, oh, by the way, if you want to do both at the same time, like your groups need to be the same. Maybe someone can deal with that. But I don't know. I think it'd be a bad user experience to have to care about what this storage underneath is actually doing. I would much prefer an interface where like Kubernetes just dictates like all storage systems shall support this interface, or not support the feature at all, and then let the storage vendors figure out how to support the standard interface. And so for snapshots, I feel like we're on a good path, right? Because an interface that lets you just pick a bunch of volumes and say, hey, snapshot these together. Users, that's very user friendly. And it might be hard for individual storage systems to implement today, but they at least know what the user interface is, and they can adjust to eventually be able to implement that interface. Replication, I like the idea of, again, implicit grouping, where you say, just take these 4 volumes and replicate them to these 4 volumes in a mutually consistent way. But you don't need a group to do that. You can express all of the grouping inside the relationship and say, I want a relationship with 4 source members and 4 destination members, and there is your grouping.
Replication might be harder if you just, snapshotting seems to be easier if you just use the labels. Replication, because it needs to do the pairing. So it's more, I guess. Yeah.
But you don't necessarily, well, I mean, if you go with a design where the grouping is implicit inside the relationship, then the pairing could be implied by how the relationship is constructed. it could literally be like, take these 4 volumes and mirror them to these 4 volumes, you know, in order. So like first one goes to the first one, second one goes to the second one, etc. And then how you create those 8 volumes is up to you. But the replication design, then at least it's simple and straightforward and easy for user to understand. But yeah, I totally agree. Like you could end up in a problem where, what if someone is trying to use both that and group snapshots, and the groups partially overlap or something, and the storage system can't do that? I say that's too bad.
Well, yeah, I think partial, that's not good, right? So
Well, but I mean,
then that's just all the members will be having both, basically. Otherwise, it will be too complicated. Yeah.
But you can
and why
imagine
you want to
use
put them in a
cases.
group anyway if only partial. So
I mean, we should be trying to design like the most generically useful tools and letting users figure out how to consume those tools. I don't want to say like it doesn't make sense to take a group snapshot of a set of volumes that overlaps with the volumes that are being replicated, but not exactly, because maybe there's a perfectly good reason to do that.
well, it basically you know, there are some certain policies, right? You specify in the study class, and then based on that, you have those grouping. So whatever meet the requirements, whatever those volumes, they will be replicated or snapshotted based on how those are defined.
Yeah, but if you want Kubernetes to control how it works, it can't be implicit, right? You can't let the storage class just magically set up replication for you. You have to have an object in Kubernetes where the user can express what their intent is, and then change their intent and say, now I want you to break it. Now I want you to replicate in the reverse direction. You know, now I want to test my failover by doing a planned, you know, a lossless break. Right? If we want to give the user the control, then we actually have to make everything explicit and not lean too heavily on magic that happens in the storage class.
Yeah. Do you know if the NetApp implementation, do they support statically provisioned volumes? I think they can, right? They can add. I believe they can add something, or maybe it's different. I think what they have, they don't really support groups, so I guess it's a little different.
Yeah. Do we have anyone from NetApp here? I'm looking at the participants list now.
It does not look like, yeah. So it's not here today.
My recollection is there's an import. You can import volumes into Trident, which is effectively like static provisioning because the volume already exists, and by importing it, you make Kubernetes aware of it. But it's a weird. It's not exactly like a static provisioning workflow in the sense that there's a PV already, and then you create a PVC that binds to it. It's that you tell the storage system, like, go create a PVC PV pair that maps to this volume that I know already exists, and it goes and does it.
And that goes with replication as well. For the replication, you can have.
Well, maybe, but like the intended design of the NetApp replication is you use the dynamic provisioner, and you tell it, I want this volume to be replicatable or something, and then you establish the relationship after the 2 volumes exist. Does that make sense? Or is someone talking on mute? Yeah.
Yeah, I was just trying to. Let me just write down this one. This is at least something we talked.
Yeah, I was involved with the design of the NetApp feature, and I'm pretty sure that the reason that we settled on storing everything in the relationship is it's the only thing that gives you the flexibility to like evolve your topology over time, right? In the scenario where you have A replicating to B, and then A is permanently destroyed, and you have to create C, and now you want to have B replicate to C. Maybe later you want to have C replicate back to B, and or you know, or you rebuild A. You know, in those scenarios, just like explicitly representing the relationship and having it point to actual volumes, it's more intuitive and more flexible.
Multi-site pairing, basically something.
Yeah, well, yeah, if you want to have A replicating to both B and C, like you can represent that fairly straightforwardly with relationships. If you want to have a chained relationship where A replicates to B and B replicates to C, you can represent that.
Okay.
But most importantly, it's all the situations where you have an actual failure and you actually have to reverse the direction of the relationship. It's much more clear, I think, to have a relationship object and to mutate it to express your intent.
Yeah. Okay. Yeah, the reason I was asking about this one is it looks like the Dell's design only supports dynamic provisioning because it's every time you have to create a new PVC for that to be
the destination of a replication.
For the replication. At least that's what they're supporting right now. I mean, it's not like they support that on the array, but I think it's what they support is you create to create a new one, and then it's going to create a remote one because it has this relationship. So they don't have the, like, you can't import something that is already there.
So suppose we developed a replication interface that everyone is actually happy with, but the Dell system couldn't implement it in its current incarnation. Like, would they go back and update the operating system or the replication software to support the blessed Kubernetes interface, do you think?
We need to ask him. We need to ask the Tom.
Oh.
I think he said that they do support, they array can support it. I think that's what he said last time.
Okay.
I think this just they just started with something maybe that's easier.
Yeah, I bet a lot of companies do that. But my feeling is that, like, we should not limit ourselves by anything that any storage vendor says they can't do. And we should design the thing that we think users want to do, and then let the storage vendors figure out how to make their systems actually do the right thing. Because if we let ourselves be limited by what storage systems can and can't do, like, we'll never build anything.
Right. Yeah. Okay. Yeah, I don't have much. I was just thinking about those are the questions that I have in my mind as I'm looking into this.
Well, how do you feel about the idea of not explicitly representing replication groups, but making them also be implicit by just having relationships with a multiplicity of volumes in them? Because that would actually be more similar to how we're doing with group snapshots, right? There's no group object either.
Right, but okay, so yeah, for that one we use labels basically, right? So it's like when you use labels and then a snapshot in time, you look at those labels and then so basically there's no group ahead of time. But for replication might be different. I think we would still need something because you need to say fail over, fail back, right? If you do not even have a group, how do you do that?
on the
Right.
relationship. Like to take the example, if I have 4 volumes over here and I'm replicating the 4 volumes over here, I have one relationship object that just enumerates those 8 volumes appropriately.
Oh, are
And-
you
and ex-
saying, are you saying, so maybe that's something that I thought this is like a one-to-one relationship. You're saying, is this a relationship you can have multiple volumes?
I'm suggesting it's a way to get around the group problem, but by just allowing the
Oh.
relationship to have an arbitrary number of volumes in it.
All right.
That's
I
how
see.
NetApp does it today.
But right now, I think, oh, okay, yeah, maybe I did not, okay, maybe I didn't.
So the NetApp relationship object allows for multiple volumes on the source and the destination. I think NetApp said they only currently allow one, but the API allows many, and in principle, NetApp could allow many. But the whole point is you don't need a group object to do this. The relationship can just say these 4 replicate to these 4, and because it's one relationship, it implies they do so together as a group.
I see what you're saying. Okay, so it's like, so it's basically you just created a mirror relationship for, I mean, so the mirror relationship it's like, it is a group basically, the mirror. So
Yeah, but it doesn't have to be a group forever, right? You can break it and then in theory form a different group later on, which I think is what users would want to do, because a lot of users are going to say, okay, I want these 4 volumes to replicate to these 4 volumes, and later on they're going to say, you know what, I really want a 5th volume, and I want it to replicate 2. So you'd like to be able to just go and.
so okay, so I guess I have a question now. Okay, I guess I misunderstood. So let's say if you have this mirror relationship, right? So let's say you have, say, A to B, but okay, so it has to be the same, right? So like in this mirror relationship, it has to be either A to B or A to B and to C, but it cannot be like some volumes are doing just A to B, others are doing the 3-side thing, right?
No, yeah.
That was
You
my.
could imagine a lot of things. In my mind, let's say you have 8 volumes. Well, let's do a simpler one. Let's say you have 4 volumes: A, B, C, and D.
Yeah.
A and B are your primaries, and C and D are your secondaries. You could have a relationship that says A is replicating to C and B is replicating to D together in one relationship. So that implies like mutual consistency or whatever. And later on, and you can then flip that relationship backwards, so like it stops replicating from A and B to C and D, but instead starts replicating backwards from C and D back to A and B. You could break the relationship. You could add a 3rd member, E replicating to F, all inside one relationship. And then you could have other relationships. So if you also want to replicate A and B to somewhere else, you could have a whole other relationship that replicates A to Z and B to Y in a separate relationship.
But I guess, okay, I guess the question is that I mean, for all the volumes in this relationship, do they have to be in, I mean, do they have to be present on the same sites? Like whether it's just 2 sites or 3 sites, do they just have to be this, I guess, the same?
Well, yeah, so I think by putting multiple volumes in a relationship, the implication would be they need to be replicated in a way that is I'm blanking on the word.
So it has to be
mutually
the same.
consistent. Mutually consistent. So like so you have right order consistency across the volumes in that relationship, such that if a write comes into volume A first and another write comes into volume B second, that the replication will reflect that ordering on the other side, right? That's what you want with group replication.
Because they have to be, yes, they have to be
is right order consistency across volumes.
So they have to be either they are.
But you could have other relationships on the same volumes going to other places, and they could be on a different schedule, and they could also be mutually right order consistent within that relationship, but not not across relationships. I wish I had a whiteboard I could draw on, but yeah, the idea is all a relationship needs to express is like what is being replicated where, what the state of that replication is, whether it's active or broken or reversed or whatever. And then by allowing multiple volumes in the same relationship, you would get that mutual right order consistency, which is the thing that you actually care about from a replication group, right? That's the only thing a replication group gives you that individual replication relationships can't give you, is that mutual right order consistency.
Mm-hmm.
So you can just sort of define that if they're in the same relationship, that's what it means. And then everything else can just be pretty straightforward. And you can have a bunch of rules about, yeah, you should be able to replicate from, volumes could potentially be parts of multiple relationships. It can be the source of one relationship and the destination of another relationship, or they could be the source of two relationships. The sky's the limit, really.
Mm-hmm.
Now, whether storage vendors can implement any of that, I don't know. I think NetApp can implement some of it, but I think that the user interface should be the interface that we think users will want to express their intent with in a way that's actually portable, and then let the storage vendors figure out if they can actually build it.
Mm. Okay, so let's see. Okay, so this one actually used it's like it has two, one on each side. They have this relationship. Right.
Sorry, I can't see my screen. Oh, there we go. I had to rotate my phone. There's two TMRs.
Yeah, so basically you will have two. You will have two relationships depending on which side you are, right? There's one. This is for
this is only if you have multiple clusters, I think. Or no, I guess yeah. If you have multiple clusters, you can have one relationship object on each side, because the goal of the NetApp design was to avoid ever having to talk across clusters.
Mm-hmm.
But yeah, I guess if you're replicating between two volumes inside the same cluster, you could just have both of the relationship objects in the same cluster, and then they do the right thing. So yeah, so one of them is sort of the destination side, and one of them is the source side. And I think only the destination one actually does anything. The source one is just sort of hanging around in case you want to reverse the direction.
Mm-hmm.
Yeah, I mean, you don't within one cluster, you really don't need two objects. I think the design here was to make it easy to go across Kubernetes cluster. I guess that's another question we would have to answer if we were designing a CSI replication, is do we care about multi Kubernetes cluster? Because the moment you get to multi Kubernetes cluster, you buy a ton of new problems, and we were really trying to avoid that with the NetApp design.
Yeah, but I think we probably need to consider that now, right? You can't. I don't think we can avoid the multi-cluster anymore. At least when you think about it.
Well, in that case, my advice is to either follow what NetApp did, because we spent a lot of time thinking about that problem, or if there is like some sort of federated Kubernetes framework that we can lean on, we can just specify that you must use this Kubernetes federation framework to do multi-cluster replication, and then design around that. I actually don't know if there's anything out there. Does anyone who's here know if we have like a federated Kubernetes framework that's widely supported?
When there is a multi-cluster SIG, right? So they do have a
Well,
multi-cluster.
I know that the SIG was formed, but did they
Uh-huh.
ever produce a solution that got widely deployed?
I have never tried that, but I'm sure there are ways to do that.
I'm not so sure. I remember hearing that like there were some various attempts at doing things, but they got aborted. But I mean, I this is years ago that my
Mhm.
memory is, so I'm sure that I'm missing the latest developments.
Yeah, and the other approach is maybe we look at that, but because we cannot dictate how that would operate, right? Maybe that we will just to figure out the storage side things, and then
Well, we
coordinate.
can't dictate federated Kubernetes, but like the beauty of the NetApp design is it's sidesteps that whole problem by saying it's someone else's job to do cross cluster communication. We
Mhm.
only need the bits that are important for the local cluster to be in the local cluster, so that the controllers can do what they need to do locally, and then everything else is someone else's job to figure out.
I think the design that Dell has, they actually do have multiple clusters involved. Their controller looks like it actually will be able to handle 2 clusters at least.
But what's the communication path?
We need to ask Tom. I don't know details, but I remember if you look at what they have here, actually it has two Kubernetes clusters actually.
Okay, I don't see Tom
Yeah, he's not
attending today.
Yeah, but I think this is another cluster. You see, oh, is this strat? Yeah, see cluster A and okay, not maybe. Let's see what about this one. This one. Side A and side B. Is that one cluster?
Well, yeah, there's only one cluster, but there's some storage over at site B that's not part of any
Okay.
cluster, it looks like.
Okay, so let's see. What about this one is 2. So class A, B, and okay, I don't know why this is stretched, but left-hand side is not stretched. Interesting. Oh, this is just 2 different. Oh, this is part of 2 different deployment. One is in this case, it's
On the left side, it is the multi-cluster case. So in that case, like my question would be, where is the control plane? How does the control plane talk to the 2 clusters? Because that was the challenge that we always faced is, do you want one Kubernetes cluster reaching out and talking to another one? Do you want to have something that's above both, that's managing them from the top? Do you want to have the control plane actually running on both sides and it doesn't matter which side you go to? Like there's a lot of models you could pick. But they all have drawbacks. And we didn't want to be prescriptive in the NetApp replication design. We wanted to say, look, you run your clusters the way you want, and replication will just work.
You see here, there is a local Kubernetes API and a remote Kubernetes API. So this one actually shows 2 clusters, 2 Kubernetes clusters. And this controller, replication controller, can create PV in this remote cluster. So this actually, I don't know where they deploy this. So this replication controller will be able to communicate with the remote cluster actually.
So it could be inside one of the clusters, it could be in both clusters, or it could be outside both clusters.
This one, yeah. I don't know where this one is deployed, or is it both or just one? Because you see this one actually, so the local cluster here, right? When this create a persistent volume, or is this remote or local? So local API, I don't know what this means. Local API create. So there is an object, somebody created this one. I think it's this replicator created the thing here. And somehow maybe this controller will be watching that and then create this. Yeah, so definitely this is for both, for two clusters, two Kubernetes clusters, some communication between the two. So this probably deployed, I'm not sure, not sure if this is deployed on both or just one. But this one needs to be able to communicate with both, I think. If you look at here, right?
Yeah, my concern with any design like this is that if we say as a working group that like the clusters must be both connected to this thing, then we have to sort of specify what the topology looks like and what the network reachability looks like, and there's security implications, right? Because now you have this thing that can talk to two different clusters, and
right,
and
yeah,
we would own all of those problems, or we would at least have to like make a recommendation for like this is how you should do it, and then maybe leave some flexibility for people to do it differently if they really wanted to, but. It gets complicated because like then the question becomes, what about your third cluster? What about your fourth cluster? Like, what if the number of clusters is changing over time? There's a whole bunch of other life cycle challenges the moment you have more than one cluster.
Well, then that depends on the relationship, right? If you just have two, then that's two. If definitely.
No, but I mean, like if we go down this path where like the data protection working group says this is our design, then like we have to write the sidecar that is the Dell replication controller box in this diagram, right? Like that becomes our code, and then we have to figure out how does it talk to multiple Kubernetes clusters? How do you manage that? What happens when you want to add a new cluster or take away an old cluster? You know, it just there's a lot of problems there that you don't have if you just say, look, it's you're inside one cluster and you can only talk to the cluster that you're in, then your life gets easier.
Right, but then that's kind of limited. That will limit us to only the first, this case, right? If we do that, it will be.
Or you do the NetApp thing where you say the two
like,
systems can operate like islands as long as someone is making sure that the information gets transmitted across, or you can punt on the cross cluster communication problem, which is what NetApp did. I mean, what NetApp really did is they designed a system in Trident which would work inside one cluster, and said the cross cluster communication problems are someone else's problem. And then NetApp built another tool that sits on top of both that actually does do the communication. But that's
Astra, right? Astra?
Yeah. But the point is like that's a separate layer that's technically optional. And the lower level layer can work by itself if someone copies the appropriate data between the clusters.
So basically, okay, so right, okay, so basically the Trident one will basically just like handle this layer, and then the Astro will be handling this higher layer, right? So
that was the NetApp design, yes.
What they have here, yeah, this one has both. This will be like in the Trident, in the Trident case. Yeah, this is tricky. Because if we don't have this, I think if we don't think about the scenario field, it's kind of limited. It only works locally. Well, today we might see this multi-cluster thing more.
Well, I mean, in Tom's doc, there's that stretch cluster picture, which we could support.
Yeah,
inside of a single cluster.
Yeah, stretch is fine. So, right. So, yeah, the right hand, this one, or this one will be easier. We don't need to have those type of communication. Is this that? Yeah. Okay. Yeah. But this one is a 2. This is a 2. Oh, this is also just a 1. This is a 1. 1, 2. Okay. Yeah. Yeah, it sounds like if we security develop something like this, that seems to be, yeah, it seems to be kind of tricky and
Yeah, I don't think we want to own all that complexity. I think we want to try to find some simple primitive which gives users the flexibility they want, that it's possible to implement the storage layer of, and then let others figure out how to stitch together multiple clusters and orchestrate big complicated things.
Mhm. Okay, Carl says he posted.
Oh, this is Sigoth, the Sigoth channel.
Yeah. Okay.
Feel free to add
Yeah.
anything to that.
Okay, so yeah, okay, so Jordan's okay, yeah, so, yeah, Jordan's, yeah, so choose that's it. So let's see if Jordan has time, if he actually has the context, it'll be good. All right, yeah, I think this is good. All right. So we can definitely start by just looking at locally first, but I think we need to have a story for the multi-cluster thing. At least need to have some proposal, even if it's not a controller. We need to talk about how it can be possibly done. Because I think we will get those questions even if we don't do it. If we have some design review.
I mean, I agree. We can't just like not specify how it should work, but if what we specify is contrary to the way other people are doing multi-cluster, then they'll criticize based on that. So it would become incumbent on us to figure out what the multi-cluster strategy is.
So I was looking at, so in this case, basically this one just has this volume mapping. This mapping or it's just local, right? Basically, it's just the local. But should this one be a pair? How does it know if it can support more than one? How does this coordinate with the remote one? It needs to be pair.
This is where you have the list, I think, if for supporting multiple volume mapping.
But that's just local. So you might make sure this is in the same order and the other one. I'm just saying, like, you have a local volume remote. So you just always make sure they are in the same order on both sides. I was wondering if it's better to have like a pair right here. Otherwise, you just basically make sure they are always in the same order. Right.
The challenge is, again, based on the NetApp design, where the TMR relationship is local to one cluster. You can't refer to object names that exist in other clusters because you can't see those objects, right? So it refers to them by handles. The handle is the remote thing.
Okay.
Because the actual name of the Kubernetes object in the other cluster could change out from under you. You have no control over that.
But then basically you do have to make sure the orders are correct.
Yeah.
Multiples. Okay.
Yeah, if you had two or more, the order would be crucial.
Oh, but this one, local and remote. Why is this one local and remote? This one has a local PV name and then remote volume handle.
Yeah, the local is an object name and the remote is a handle because it's proprietary, right? It's not inside you can't refer to the object in the other cluster.
Okay. Okay, okay. So this will just be okay. I have the names of that. Okay, yeah, I will think about this. So I think if it's like this kind of grouped by this, then maybe it could be possible you know, those volumes, they might be also in this other like volume group snapshot grouping. Let's say, you know, your A might be in.
My preference is to keep the two entirely separate and say snapshot groups are what they are. Replication groups are also what they are. And if users want them to overlap, that's fine. If users want them to not overlap, that's also fine.
Yeah, I need to figure out how they can work together, even if they, let's say, if they're kind of separate, because because I do have the use case. If I don't consider that, then you know, then that means they.
Well, I think the easiest way to get them to work together is to always make groups implicit and never explicitly represent them. Then any coincidental overlap is just coincidental, and you don't need to explicitly represent it anywhere.
You basically just make sure the volumes are kind of in both.
Yeah, if you want to have them be the same, you always use the same list of volumes when doing your operations.
Okay.
You can even represent the group outside Kubernetes at that point and say, like, I know that these 4 volumes are part of a conceptual group that always gets snapshotted together and always gets replicated together, and that fact lives outside Kubernetes.
Okay.
Did you have anything else on the agenda today, Xing?
No,
we're down to like
that's
a couple minutes.
Yeah. I think we can. I think we're done. Are there anything else from Carl, your side, or we're just basically waiting? Oh, actually, let me put this. Okay.
Nothing else on my side at this point.
Okay. Just let me just put it here so we know that we pinned. Yeah. Okay. All right then. I think then that's it for today. Thanks everyone.
Okay.
Thanks for hosting, Xing.
Bye.
Thanks, folks.